Lesson 5-4, Solving Compound Inequalities with the connecting word and, Day 1. Our essential question is, what are the three types of graphs that may represent a compound and inequality? So our first new vocab word is compound inequality. A compound inequality is like a compound word. A compound word is made up of two or more smaller words. When put together, they form a new word. So a compound inequality is when you put together two or more inequalities. And they're connected by the word and or the word or. Okay, so now focusing on the connecting word and today, we have a picture of a Venn diagram and the word intersection. The word intersection is the one that we can use when we're using the connecting word and. Because an intersection of sets is where they overlap. So in my Venn diagram, the two circles intersect here in the part that I'm coloring in green. So this is the area that represents the intersection of the two circles. What that means is it's where the circles overlap or what they share, what they have in common. So that's what we're going to be looking for with our inequalities today. Where do they overlap? What points do they have in common? So intersection, because we've got a connecting word of and. Here's another example of using that connecting word and to just get you thinking about real life. To be eligible for the presidency of the United States, a person must be an American-born citizen and at least 35 years of age. So that connecting word and means that you have to meet both of those requirements. So to meet both of those requirements, you're going to be in that intersection of the two sets right here. So it's not the people that are just an American-born citizen or just greater than or equal to 35. It's the people that meet both requirements. So have to meet both requirements or have to be in both sets. To be in the intersection, you have to be in both sets. So transferring that over to our inequalities, we're going to solve and graph two linear inequalities, and then we are going to be looking for the numbers that are in both sets. So we will have two rays, and we'll look for their intersection. So my first inequality can be solved by subtracting 1 on both sides. That will give me 5x is greater than or equal to 5. Then dividing 5 on both sides will give me x is greater than or equal to 1. I'm not going to draw my graph yet because I don't know what my other number is, so I'm going to solve the second one first before starting my graph. So I add 7 on both sides to get 3x is less than or equal to 12. And I divide by 3 on both sides to get x is less than or equal to 4. So my number lines need to go from 1 to 4. And I'm going to use two different colors here. My first one, x is greater than or equal to 1. I'll graph in black. So it's a closed circle since greater than or equal to, since there's a line underneath the greater than. That closes my circle, and greater than means that my ray goes to the right when the numbers are larger. Now my second one I'll graph in blue, less than or equal to 4 is a solid circle, closed circle on 4. Less than goes to the left where the numbers get smaller. So there's my second ray. So now, if I look for their intersection, where they intersect with each other, I notice that they intersect with each other starting at the 1 and ending at the 4. Ending at the 4. So from 1 to 4, that's where my rays overlap each other. So I'm not looking for the part that's only blue or only black. I'm putting them together, just like the Venn diagram, and looking for where they overlap. Now, to write this as an inequality, I have my boundary numbers 1 and 4. I know that my variable is somewhere in between there. It makes sense to me that I've got a less than or equal to, x is less than or equal to 4. That makes sense to me because it's going to the left. But on the other one, it's going to the right. So what I actually want you to do is I want you to look back up here where I'm circling, and I want you to turn that inequality around like this, because then I think you can understand where my interval comes from right here. So the symbol that I need after the 1 down here in my interval is a less than or equal to. So because I've reversed the inequality to get the x on the other side, 1 is less than or equal to x, which is less than or equal to 4. So again, up here, I circled this, I flipped it around, right here I flipped it around because it's got the same meaning. X is greater than or equal to 1 is the same as 1 is less than or equal to x. Then if I drag this over to combine with my other inequality, you see my interval. You see my compound interval. So I don't need to write two separate inequalities with the word and in between them. An interval graph should have an interval inequality to go with it. So there's 3 pieces to the interval, 3 pieces, not just 2. So this is the first type of situation that can happen when you solve and graph your 2 inequalities connected by the word and. They could create an interval. Okay, the second thing that can happen. So now on this one, I'm going to solve and graph again 2 completely separate inequalities. The first one is just one step. I need to subtract 5 on both sides, so x is greater than -1. The second one, I would subtract 7 first, so -2 is less than or equal to -6, and then I divide by -2 on both sides, which flips my symbol the other way. And a -6 divided by -2 is +3. Now I'm ready for my graphs, so I'm going to go from -1 to 3 on both of them. Well, actually on all 3 of them. It really works out best if you line up your graphs like what you see me doing, so that it's easy to see where they overlap. If you draw your number lines side by side instead, it's a lot harder to visualize. So if you have one number line right above the other, I think it's the best way to go. Greater than, first one is x is greater than -1, so it's an open circle going to the right. My second one is greater than or equal to 3, so it's a closed circle and it's also going to the right. So this one is different from my last one. My last one, the rays were not going in the same direction. So what happens when we intersect these? When we intersect them, you notice that, remember I'm looking for where it's red and green. Not just red, not just green. So both colors start at the 3 and go to the right. So my intersection is actually just x is greater than or equal to 3. So I don't have two inequalities in my intersection solution. I don't have an interval with two endpoints. I just have one ray. Because when the rays are going in the same direction, that's what's going to happen. Where they intersect is still going to be a ray. Okay, the third type of intersection is called an empty set. And what happens on this one, these are basic, so they're ready to graph right away. So I can just draw my graphs from 2 to 6. So what happens on this one, if it's an empty set, is you should see that there is nothing in the intersection. Greater than 6 is open going to the right. And less than 2 is open going to the left. So these rays, if I click and drag to put them together, they do not overlap. They do not overlap. So we're looking for the intersection. We're looking for the intersection. We're looking for numbers that are on the first ray and the second one. There aren't any. There aren't any. So I'm not going to graph anything on my number line at all. And I'm simply going to write for my inequality empty set. There are no numbers in the intersection. It's impossible to give me a number greater than 6 and less than 2 at the same time. Because these numbers that are greater than 6 over here, none of them are less than 2 at the same time. That's impossible. So there are 3 completely different things that can happen when you solve 2 inequalities that are connected by the word and. 3 completely different things can happen. And that is what you should be writing about in your summary. Please make sure that you answer the essential question and use complete sentences.